Welcome to the fish farm! Is the lens cap in the way?
In today's video, I'll be going over the layout and design of my commercial fish farm. In 2024, I used the farm to raise over 12,000 Atlantic croakers. And hopefully, after this video, you'll have a better understanding of how the filtration and system work to keep the fish happy and healthy. Stay tuned as I plan to make a series of aquaculture videos just like this one. Let's start with the fish tanks. We've got 11 tanks in total. The blue tanks are 650 gallons and used for the grow out. And then we have 3,000 gallon troughs which are used for grading and sorting. For aeration, a 1.5 power blower. And for the water, we have a 5.5 horsepower pump that pumps 500 gallons a minute. Both water and air are pumped up 12 feet through the ceiling and then to this loop. Similar to an irrigation sprinkler system, the loop is designed to create constant head pressure to each tank. For distributing the water around the building, I use 3-inch PVC. And the drop downs into the individual tank are 2-inch PVC. And for the air, the main is 1.25 inches, and for the drop downs is 1/2 inch. Now each tank, air and water, has their own valve that I can control the different flow rates. But with the water, I have union valves that I can also control the direction in which the water is flowing. And for the drain system, we have a 3-inch bottom drain followed by a surface 2-inch drain. The bottom drain is an external standpipe. As water flows into the tank, it has to come up through the standpipe and out into a drain manifold. To empty each tank, you have to use this 2-inch valve. A household sink drain uses a very similar system called a P-trap. Each tank drains into a 4-inch manifold. There's 2 4-inch manifolds, splitting up half the tank drains. Each 4-inch pipe meets out the back of the building and into the sump, where it can be filtered and then pumped back into the system, completing the recirculating aquaculture. To empty the tanks, for either moving fish or cleaning tanks, I need to use this 2-inch valve. When open, the water flows into this 3-inch manifold out the back of the building to this valve. When the valve is open, all the water from the tank is pumped back into the sump. The objective of the recirculating aquaculture is to save as much water as possible. If I need to discard the water, I can direct the water into my waste settling bin, where the water can be pumped out and used as fertilization for saltwater plants. Next, we're going to dive into filtration. First up is our mechanical filtration. The filtration is very similar to any household fish tank. We start with the mechanical filtration, and this is where all the solids are taken out through these screens. Each screen color is different sizes, so as the water passes through, it goes into smaller and smaller holes. From the mechanical filtration into the sump to the pump, pumps the water up. 80% goes back to the fish tank and 20% into this loop, which is the filtration. Each filter, like the tanks, has their own valve. In no particular order, we're going to go through each filter, starting with this little bead filter. This little bead filter acts as a pre-filter to the biofilter, making sure no solids go into the biofilter. The biofilter is a chemical filter, removing all ammonia, turning it into nitrites and nitrates. Each ball has a certain amount of surface area that the denitrifying bacteria lives, meaning the more balls, the more surface area, the more bacteria, the more nitrification can occur. That's as simple as I can make it for now. Next is the protein skimmer, which if you have a saltwater tank, you're probably familiar with this filter. Uses tiny bubbles, mixes it with the water to remove any organic waste from the water. And I want to make another video going into detail on how I built this because I used a pretty unique design for the filter. Next filter is another bead filter. To explain how a bead filter works is it's very similar to a sand filter. Water goes through the media, waste gets collected, clean water comes out. The bead filter leads into the incomplete algae turf scrubber. Algae is the greatest filter of all time. You can almost achieve 100% no water change by using algae. It removes the nutrients produced by the fish like ammonia and nitrates, also removing any metals that could be found in the water, all while reducing the CO2 by creating oxygen, which in return increases the pH. This is really a all-in-one filtration, not to mention it gives you an amazing crop, which is algae. And in this case, I am growing sea lettuce and whatever else wants to grow on my turf scrubber. And to complete your tour of the facility, because I got distracted, we have the reservoir. The reservoir acts as extra water if a water change is needed or if there was an emergency. There is a float switch. As the sump goes down, the water comes in. I also can run it in line with the system if needed. That completes the brief overview of the system. I could break it down further and go into stocking densities, flow rates, and all that kind of good stuff, and the brood stock system, and little tricks I do with air to dry the drains. But to keep this video palatable, I'm going to end it here. If you have any questions about the system or suggestions on my next video, please let me know. The fish farm is also empty, so ideas for the next fish to raise at the farm will be helpful. Thank you.